All right. Today is um, June 22nd, 2025. My name is Christian Espinal, and this is our Module 6 Generics Programming Project. So, um, first, we were tasked with, just explaining, like, the core concept of what this project revolves around. So, in general, like, we're using generics, right? And they're utilized as a means to improve the organization of code and help detect compile time, bug errors, and more early and stuff. They enable types to be parameters when defining a class, and we receive stronger type checks at a compile time. They also eliminate the need to cast and enable programmers to implement like genetic algorithms, which work with collections of different types and offer a great deal of flexibility while being easy to read. And so that's what we're going to showcase today with this project. So we're going to start with with these classes I have here. So let's start all the way on the left. This generic search. So this class holds within it an index function, a find index function, which takes an array and a value, a generic array and a value of the same type. It will return the index of the first match while returning -1 if the value is not found, signaling that the value isn't found in the array at all. All right. The next we have this Pokemon class. So we use the Pokemon class to instantiate Pokemon objects, which we'll put into our collection. So this is going to have three different parameters, attributes, a string with a name. Each Pokemon going to have a name. Each Pokemon going to have a level, which is an integer, and each Pokemon going to have a moveset, which is an array list of string. Right. So in our constructor, we are going to pass into every new Pokemon object we instantiate the name, the level, and the list of moves that it's going to have available to it. We have our get name, our getters, our setters that are necessary, and it is standard procedure. And we have our overriding toString. This is going to take in the name, the level, and the moves, and just going to, when we print out this object, we're going to get this unique this statement when printing. So now we have our trainer object, and this we have string and int. So these are both to the same attributes, but then we're introducing a boolean that this class, the trainer, is going to have in every object it makes. This is our constructor. We're passing in the name, like the badges that each trainer is going to have, and if the boolean is if they're undefeated or not. Then we have our getters and setters here that we're using the standard procedure, and this is their override statement, our toString. And then we have our gym class. So this gym class is always going to have two strings. It's going to have the name of the gym. Each gym is going to have a certain type, and each gym is going to have an average number of challengers that they get a day. Okay, which is going to be a double. So we are passing into our constructor. This is how we make our gym objects. We're going to pass in a name, a type, and a number of challengers. And these are our getters and setters, of course. Right? And then we have the generic container. So these are going to hold all of our objects, right? And the cool thing about the containers is since they're generic, they can hold any kind of object and the object's data types, right? So these are all the functions, these are all the methods that we are going to call upon each container once we create them. So we're going to add these objects to the containers that we create. We're going to remove them. We're going to retrieve their index with this retrieve method. We're going to grab their sizes, and we're going to print them, of course, and sort them. Right? We're going to see all this action happen here. So let's talk about the descriptions of what we were tasked with. So the first problem description, we were tasked with writing a method that takes an argument as an array, and one of the values from within the array, as we said, this is what this generic search was for, to accomplish. It's going to return the position of the value in the array using generic parameters, as we are showing here, so that the array can have different values, value types passed, with the same method calls being used. So let's see what we're doing here. We're creating an integer array that'll hold integers. We're instantiating a string array that's going to hold strings, and we're going to instantiate a double array, which will hold doubles. So when we, oh, my bad, I'll just run this again just in case. And so yeah, so we're going to print out on our generic search, we're calling find index on generic search, right? And we're passing in the int array that we established, that we instantiated, and the value within that array that we want to index, right? So I want to find the index for 6. As we know, we'll start with 0, 1, 2, 3. So there's 4 items in this array, but obviously the first index starts with 0. So the index goes up to 3. So 6 is at 2, and we're printing 2. Returning the index of 2, right? And this is a integer, and we're using the same function for all of these, but we're passing in different values. That's the power of generics, the flexibility. So we're using print. We're printing out, calling find index on generic search, passing in our string array, and we're looking for blue. Now in this case, we have 0, 1, 2. It's still the second index, and we have a 2 here. Yep, looks good to me. Now we're passing in a 2.2 with the double array, right? Double arrays taking doubles, using double array, still the same method. In all 3 of these, 3 different kinds of arrays, 3 different data types, all using the same method, showcasing generics. Now we are instantiate. Now we're getting into our second problem that we were tasked with. So we were tasked with picking a TV show for types of data for the types of data that would collect and perform basic operations on them, right? So I chose Pokemon. It's a TV show I grew up with, and so as we talked about earlier, each class is going to have different types of attributes, various, like a lot of them use strings still, but each one has a unique attribute to it. In the case of trainer, it's booleans. In the case of Pokemon, it's the array list of strings that they have for their moves, and the gyms are going to have the doubles, right? So to create a Pokemon, we first have to give it a moveset, right? So I'm instantiating here. I'm listing list objects to hold the move of each Pokemon object. Yeah. So we are creating a new array list as a list, arrays as a list, and we're passing in these 4 moves. In Pokemon, in the games, they each can learn up to 4 different moves. So we are instantiating an array list of strings and making called pincer moves. And this is a new array holding these 4 moves. We're doing the same for Blissey, and we're doing the same for Dragonite. These are going to be their move sets, which are going to be passed in to the Pokemon objects, right? Because we need these kinds of we need an array list of string to pass in to Pokemon objects created in the first place. Here next, we're instantiating a new generic Pokemon container. This container is going to hold the Pokemon, right? It's still a generic container. We're still a generic container, right? But this one's we're calling it Pokemon for the sake of simplicity. But they're all going to be new generic containers. So we're instantiating new Pokemon objects now. So we're going to make a Pokemon called Blissey, and it's a new Pokemon. It's called Blissey, right? We're passing in the name, the string. We're passing in the level, the integer, and we're passing in Blissey moves, the array list string that we created, that we instantiated. Doing the same for Pinsir, and we're doing the same for Dragonite. 3 different Pokemon, and now we're adding each of them to the Pokemon generic container, right? So we're adding Blissey, we're adding Pinsir, and we're adding Dragonite. So then we print them, and in this print, in our console over here, in case you're having trouble seeing, I'll just zoom in a little bit. So we see our list of Pokemon, and if we can go back to Pokemon, we see in our override toString method, we can follow this. This is a blank. This is the name of the Pokemon, and it is level blank plus the level. It has a moveset of, and then we put in the 4, right? So interestingly enough, the override statement is coming into effect here once we're printing. And so this is a Blissey, and it is level 68, right? Blissey, level 68. And its moveset of Soft Boil, Seismic Toss, Thunder Wave, and Teleport. Right? Our Blissey, Soft Boil, Seismic Toss, Thunder Wave, and Teleport. We're getting it all. Pinsir's getting the same. This is a Pinsir, and it is level 7. How do we know it's level 7? Because in Pinsir moves, in our instantiated Pinsir object, we have our level 7 tag here. Level 7 has a moveset of Hidden Power, Stone Edge, X-Scissor, and Earthquake. And then finally we have our Dragonite, it's level 72, and this is its moveset. So we've been able to add Pokemon objects to our generic Pokemon container. Alright, so now we're gonna sort these Pokemon containers, right? So we're using our Pokemon generic container and calling the sort method. Whoops, sorry about that. We're calling the sort method using our comparators, calling comparator, and we're using the C to get name, right? So this is going to sort the characters. This will sort our list of Pokemon. As you can see, Blissey, Dragonite, and Pinsir. The list is sorted. Blissey is alphabetical, D followed by P, and we're printing container. So now we go on to our next class of objects that we want to put into containers. We're doing the exact same thing, but this time obviously trainers have an undefeated Boolean value, right? So we instantiate a new generic container for trainer. It's a new generic container, still a generic container. It's just that we're calling this one trainer for the sake of readability, and we're making 4 new trainer objects: Ash, Gary, Oak, Brock, and Misty. Right? These guys have 8 badges. Brock and Misty have 1 and 2, and they're false. They are not undefeated, and Ash and Gary are undefeated. We're adding them, doing the same things we do with Pokemon, and then we're printing them out. So let's look at our trainer, our toString method. This is trainer name, and they have badges. It is undefeated that they are undefeated. All right. So let's read this. This is trainer Ash Ketchum. Okay. This is trainer Ash Ketchum. We have that name. They have 8 badges. We have 8 badges. It is true that they are undefeated, following the Boolean value. It is false that they are undefeated for Brock and Misty, right? They are false. Gary's also true. So then, from here, we're going to use our retrieve method to showcase generics, right? We're going to loop through our container, right? So in this loop statement, we're going to go through each index of each element of the container, its whole size, and after every element, we're gonna increment, right? So T is capturing the index of the container within the container, right? For just so we can put in this if statement, we can check if this trainer, right, is undefeated, gets undefeated, right? So what's happening here? We're going through our first Ash Ketchum, right? We're grabbing Ash Ketchum, and we're retrieving I. This is him. He's captured. And now we're calling get is undefeated. on Ash. Well, is he undefeated? It's true. He is undefeated. So we're just gonna print out Ash. We're just gonna print out Ash. He's an undefeated trainer. We're also going to do the same with Gary. Gary's also undefeated. So we're gonna pass through, iterate, and Gary's here. And Brock and Misty are not, because they are not undefeated. They are not. And that is showcasing our retrieve method. And now finally, we're instantiating a new generic container for gyms. Same generic container, same class, but we're holding new objects. We're holding gyms. So we're instantiating 4 new gyms. Viridian, Pewter, Cerulean, and Saffron. They have 4 different types, and they have 4 different average numbers per challenger of challengers a day. We're adding each gym into our generic container, our gym generic container, and then we're printing. So here we have the gyms, a list of gyms. This is the Viridian gym. It is a ground type gym. On average, the Viridian gym gets 17.3 challengers a day. So if we look at the gyms, we go to our toString method. Oh, whoops. Let me just put that there. Save it. Yeah, I just noticed that. Sorry about that syntax. But yeah, this is our toString method. This is printing every time we're using gym objects, right? Pretty cool. So we're gonna get the size of the gym container. We're using our size method on the generic gym container. And notice how it's the size of 4. We have 4 gyms. Okay. So what if I wanted to see what if I just wanted to remove the gyms with less than 40 average numbers of challenges a day, right? So we make this this loop. So for I, and I being less than the gym container size, we're going to increment. We're iterating through our gym container, right? We're grabbing gyms. We're doing the same thing with trainer. We're capturing the index run with retrieve as G. And now we're doing another if statement. So if this gym, and then we get the average number of challengers, and if it's less than 40, so we're calling our get average number of challengers method and checking if it is less than 40. We're gonna run this block. So generic gym container remove G. We're removing that object from our collection, right? Because it's less than 40. And then we're de-incrementing I. So why are we doing this? Well, when I ran it, I would run, it would loop through the gyms, the container. And the first one is Viridian, right? Viridian has 17. Interesting. So it'll capture that. That's less than 40. We're going to remove. But if I didn't have this remove statement, this would actually remove it from the container, and then there would be 3 objects within the container. But once that was done, it would still increment the index, right? So we wouldn't actually read Pewter at all, because we were passing it. We were already past it once that first entry was gone, once Viridian was gone. We would just go to Saffron, and we would just go to Cerulean. We would just go to Cerulean and Saffron. We would never see Pewter. So that is why I noticed that. That took me a while to find, because I was still getting 3 entries. I was using system printout and just printing out the container, the container size after every single time, and it wasn't coming up, but it was still Pewter was still there, but it wasn't getting printed out and caught with this. So that's why we have these I decrements here. And then else, if it is above 40, we're printing the object with an average above 40, right? And so then finally we're showing the size of the container afterwards, right? So as you can see, Viridian had 17.3 challengers, so it gets dropped, but the 3 remain and they get printed from our loop, right? Then we print the size again of our container, being 3, showcasing that we did in fact remove. And yeah, that is my generics demo. Thank you.